Hello and welcome to creating control charts on Minitab Express. So today we're going to be looking at building charts of X bar, R, and P and C. So I have a couple different data sets that go along with this document that we're going to be covering today. So if you don't have those open, you might want to do so now so that you can follow along with me. If not, well, hey, you can open these later and make sure you know how to do this. This isn't too difficult to do. The only downside to Minitab Express is that there are some requirements that it has that 17 does not, especially when it comes to building the X chart and the xbar-r chart. So the first thing I'm actually going to do is close this navigation panel because I'm going to run out of space real quick when it comes to making these. And make this just a little bit squelched here. All right, so the first data piece I have open is the circumference of baseballs data. So this is the sample number, so the order it was taken in. Their circumference is for those samples, and then the standard deviation. So you notice when I gathered this data, I was not given sample size. We don't know that for what's happening here, and that makes this chart a little bit harder to build in Minitab Express. So we're going to head over to the Statistics tab and then click on Control Charts. If you have this a little bit wider, you don't have Control Charts, you just jump all the way to Continuous to do this. So I'm going to click on this and then choose Continuous. And notice we have only 5 options here. We're not going to be doing any of the individual tallies. We're actually going to do the X bar. Notice there is no R chart, so to do an R chart like we're going to have to do later, you have to do an X bar R, which produces both of them. So we're going to hit X bar. And then it's going to ask you, hey, where's all your data? Well, mine is all in one column, so I'm going to go ahead and put circumference in there. Now it's going to ask you, are all your subgroups the same size? We don't actually know what size they are, so I'm just going to place a 2 in here because that's the minimum number in order to get this thing to do this. And that's about it. Normally, we know what size our subgroups are, and we need to input that, and we will do an example with that in a little bit. Let's go ahead and hit OK. Alrighty, so this chart doesn't quite fit. You can almost see it. Hold on, I'll scroll down so we don't have a title, but you'll be able to see everything. All right, so here's the X bar for circumference. Notice it did it in order. It assumed your data was in order when it created this. If you're looking over at your notes, you'll notice that the value calculated for the upper control limit and the lower control limit that I've done don't quite match this because it's using that 2 to decide these. So you should calculate these by hand when you're doing this to make sure you don't have that issue. Or make sure you know your sample size so you don't have that issue. Alrighty. So next up, I'm actually going to switch our data to the ComTech data. Is that ComTech? No, that is the one I already have open. There it is. So just like before, I'm going to close the navigation pane so you can take a look at this. So the ComTech data has its samples arranged in the data plane. So basically, row number 1 with these 5 values makes the first sample of size 5. So here's the first measurement, second measurement, third measurement, fourth measurement, and fifth measurement that go into sample 1. So we don't have the mean or standard deviation or range already calculated. We're going to rely on Minitab to do that for us. So just like before, we're going to go up to Statistics. We're going to go to Control Charts. We're going to go to Continuous. And now I'm going to be choosing the xbar-r because I want to produce an R chart, and I can't produce just an R chart. And here's where we're going to have a little bit of a problem. It's like, hey, are all your data in one column? They are not. So I need to notice that I have multiple columns, 1 row for each subgroup. So it asks you where are these columns located, and you can go ahead and put them all in here. Alrighty. And then we're good to go. And this will calculate everything for us as well. So we're going to go ahead and hit OK. And it's going to give you the X-bar chart. So there it is. And then right below it, the R chart. Unfortunately, this is the only way to produce an R chart in Minitab Express, at least according to this method. One thing worth noting is that since it knows for control processes and producing anything at all, it's not possible for you to get something below 0. It's automatically setting your lower control limit to 0. Fun times. All right. So I want to go back and mess with the settings with this a little bit now that you've seen what an R chart looks like. So I'm going to go through the same steps again. I'm going to go back to Control Charts, Continuous, and then xbar-r. And I got to reset this. So multiple columns each subgroup. Putting them back in there, and then I want to mess with the display a little. So one of the downsides to using Minitab to produce these is it's not always easy to look at that graph and tell when your process is in control or out of control, especially since out of control is usually defined by how many standard deviations you are away from the mean, or the center line, or the mean of means, aka R bar for the R chart, so the mean of ranges. And what's weird about that is like it doesn't mark it doesn't mark the standard deviations for you, so it can be a little bit harder to tell when you're too far out. And we can actually do something about that. So if we click on the Display tab, you'll notice there's this option down below. Hey, do you want to display the additional sigma lines above the center line? Heck yeah, we do, because that'll tell me when I've got some issues in my processing. All right, let's go ahead and hit OK. Woohoo! Okay, so that's the X chart. Everything looks pretty okay. I do have two that are above 2 standard deviations away from the mean right here. That's a very concerning thing for me, but most of them are within 1, so the X bar looks okay. So our mean of means, or our average of the averages for this sample, looks pretty good. And the ranges looks even better. So you have on here some labeling that's occurring on this side. I'm going to make this just a little bit bigger. So it's leaving you the lower limit, the 2 standard deviations above, 3 standard deviations above, and so on and so forth from each direction out from R. So this will allow you to say, oh, well, how many do I have above 1 standard deviation away from the mean? Well, quite a few, and just 1 above 2, and the rest are all within 1 standard deviation of the mean. I just lied because there's some on the bottom that are not. Schwoops. But it's much easier to read this now that you have the bars marking where those standard deviations are, and when you're trying to go through your 6 steps to determine, is this in control? Luckily, this process is in both cases, which is kind of fun. Yay. Anyway, so I'm going to scroll down, and now we're going to make ourselves a p-chart. So in order to do this, I actually need to change again to another data set, because when dealing with the last two data sets, that we have, they were both quantitative data, which means I can do an X bar and an R for it. But in order to make a P and a C, we should be dealing with categorical data, since those are the charts that are for categorical variables. So I need some categorical data. So goodbye, Comtech. Goodbye, baseballs. Hello, number of defects in wafers. So we talked about wafers in some of the examples in the notes, and we're going to look at counting number of wafers that have defects in based on the number of hours we are in production. So one thing to notice about this wafering process is that my samples are not always the same size. So there's some inconsistency in sample size, so we're going to have to input our sample size when we're going to give this to Minitab. So just like always, we're going to go back to statistics. I'm going to go to control charts, but here I'm going to the attributes charts. That's where you find all the ones for categoricals and proportions. And I want to do a P. Alrighty, so the first thing it's going to ask you is, hey, where's the number of defective items? Well, that's in number of defects. And then it asks you for what size are the subgroups. And right now it's set to all subgroups are the same size, which is not true. We have different sample sizes. So we got to tell it it's in a column and tell them where that column is. I'm going to go ahead and hit display again to have it give me those 2 standard deviations away from the mean. That way I can see those a little bit easier when it comes to deciding the control of my chart. We're going to hit OK. And this should produce a lovely chart for us. I'm going to make this just a little bit bigger. Alrighty. So as you look at this chart, there's a couple things to notice. Just like before, it gives you your upper and lower limit. Because I requested those 2 standard deviations in each direction, it's giving me those as well. And there is my mean of P's, or my P average of my sample proportions. And I'm hoping you look at this and you're like, well, that's super not straight. What's going on here? It's all bumpy. Why are my control limits like all over the place? Well, if you remember back from the notes, when we're calculating the spread or standard deviation for this, we're using the sampling distribution to do it, which has standard deviation, the square root of P times Q divided by the sample size. Well, if all my sample sizes are different and all my number of defects is different, my P's are all different, and my sample size is all different. So that means when I look at all the spreads for all these samples, they might all be very different from each other. Just how different? Well, that depends. Looking right here in the middle, it looks like everybody's pretty stable, but there are a few places where it looks very, very bumpy, and that's a good indicator that you've got a little bit more spread there. And and this is called staircased, in case you were wondering, and I wrote about it in here for your enjoyment. Anyway, so as you look at this, you should be looking out for the same, well, it's not the exact same characteristics. There's only 4 for when you're looking at P and U for this guy. So be aware of that.